Hi, my name is Jake Vostenkemper, Director of Agronomy and Research here at Liqui-Grow.
Hi, I'm Katie Hess, Director of Sales and Marketing here at Liqui-Grow. Dr. Jake, we are here to do Elite Academy. And knowing you, we've now taken ExactStrip for fertilizer and we've turned it into a whole family of products.
Oh, nice. I love it.
Yes.
New technique, innovation.
Yes. And, we've been talking about ExactStrip for years, but, the more I hear about it, the more keeping that nutrients in the root zone, allowing that plant for uptake easily, especially in some of the conditions we've faced the last few years, just makes a lot of sense.
Absolutely.
Well, we can quit then.
Yeah, we can just be done.
No. Let's hear the science and the data behind everything that we just have started to talk about.
I think that we have to take a step back for a moment, okay? And although we're going to talk about the ExactStrip family and basically how can you use precision placement in many different to solve several problems on your farm.
Sure.
Okay. I mean, that's what it's that simple.
You've got the technology, we might as well use it.
It's that simple, right? But we need to back up and we need to talk about a fundamental of agronomy. If you remember, I think it was last winter,
I don't know.
But we had a Lead Academy session on the fundamentals of agronomy.
Back to the basics. That was a good one. We'll link that down below.
We can talk about all sorts of new technologies you want. But if you forget about the fundamentals, all this goes out the window.
Right.
Okay? And so on that, before we start talking about ExactStrip and how ExactStrip could be used, I want to talk about some fundamentals. Okay. So as many of you probably know, our 15-inch dribble banding is the core offering that we use today. I mean, that's been the bread and butter for a long time.
Right.
Okay? And let's talk about why the 15-inch dribble banding is a fundamental aspect of agronomy and how this ExactStrip is basically the icing on top. Let's get a little bit better. Let's take the fundamental and make it a little bit better. Okay.
Right. If that's what you've got available to you, you shouldn't feel bad about that being your option.
No, absolutely not.
It's a great option.
Yeah, absolutely not. And so why is 15-inch dribble banding a fundamental of agronomy, right? Number one, and probably most importantly, is uniform application. Go ahead.
What does that even mean, Jake, for a lot of folks?
That means that you need to apply the rate of fertilizer that you need to apply to that field to maximize economic return from the first nozzle to the last nozzle of that pass. You need all of that to be the same.
And the products inside the tank are always the same.
Yeah, we're going to come back to that.
Oh.
But yes, you're right. I was just at the ICM conferences in Ames, and the Ag Engineering Department talked about non-uniform applications and how that can affect yield. In fact, they showed some yield data on that. And if you're not uniformly applying nutrients, particularly nitrogen and sulfur, that does reduce corn yields and soybean yields too. And they said that in black and white, okay, and showed it.
Another way to say that too, Jake, is if that's what you're doing, you might not know that you've got yield loss, right? You're just used to these yields. So if you did it a little more precisely, like you're saying, these 15-inch dribble bands, you might actually capture some more yield opportunity.
Right.
Because these hybrids we're working with today, I mean, they say, 600 bushels potential in a bag before you even open them.
Yeah, and not only do they say, well, we've recorded that now. Yeah.
So once you open that bag, yield potential just starts kind of floating away. What things can we do to keep that yield potential?
You could have gave the engineering talk. That's exactly what they said.
Gosh, it's like I've done this before.
They talked about job quality in general.
Right.
And how doing a poor job quality is going to take the yield potential of that crop backwards. So everything you do in season that's not as perfect as you can be agronomically reduces the yield potential that crop had. And guess what? Uniform application was one of those job quality things that they were concerned about. And they showed some data, right?
Sure.
So nitrogen, sulfur, important every year on every acre. P&K, levels in the soil, if you're below the critical level, which is about 180 ppmk and about 20 ppmp, if you're below that, non-uniform application is going to also reduce yields when it comes to P&K application.
Application in general is important at that point.
Absolutely. Fundamental of agronomy.
Right.
And that's why the 15-inch dribble band, the most important reason why it stands out. When I first got here in 2015, I started doing a series of on-farm replicated trials I was applying the fertilizer, but the farmer harvested the trials. It was a cooperation project. Over 24 replicated field trials across our geography over 3 years, there was a 5 bushel yield increase to the dribble banding approach.
And that's just on farm farmers,
Yep.
real life
field
stuff.
strips, 1,000-foot strips.
So research
they
is
weren't-
great,
they weren't
but
1,000-foot, but 500-foot strips.
research is great, but when you actually are doing this in the field with real farmers, I mean, that's more realistic and
Yep.
more real life. And
Yep.
that's the graph we see on the screen
That's
right
the
now.
graph you see on the screen right now. In addition to the uniform application, you talked about product uniformity in the tank,
Right.
right? Another thing that we know can happen with dry fertilizer is that after it's blended, from the sifting and the shaking from the plant and the truck and the floater, P and K can segregate, but it's particularly the micronutrients that segregate, okay? And we've seen in a lot of what I discussed how important zinc can be. There can be some big yield increases to zinc in places. So, with suspensions, we know, because I've measured it, it's so crazy to say this, but literally every drop has the same concentration of micronutrients because I've measured it. I was even blown away of how consistent it is from sample to sample to sample to sample. Okay. But it is not that way with dry fertilizer. Okay. So that's another important aspect of these liquid suspensions and fluid fertilizers in general. The last thing is the banding and the placement. We know from all of my research that banding most definitely can be important to keeping mineral nutrients available and increasing plant uptake. Does it matter more sometimes than others? Sure it does, okay? But in general, it definitely can matter, and oftentimes it does. And we also know from my own work developing ExactStrip that even at 6 inches away, we still see a yield increase relative to broadcast, okay? In fact, if I remember back at that data, banding in general increased yields relative to broadcast, even if it was 15 inches away. But it was particularly clear at that 6 and even 9 inch placement was slightly higher than the 15 inch placement, okay? So that again just shows us that even if that band of nutrients isn't concentrated right by the roots, the banding can still increase yield. So for those 3 reasons that I mentioned, that's why I speculate, that's where I speculate this 5 bushel yield increase came from.
So I'm going to stop you right there, Jake, and just talk about that 6 inches, 9 inches, and 15 inches. You're talking 15-inch dribble bands. Are you referring to 15-inch dribble bands, but you're actually saying the placement's going to be that 6 to 9?
Yes, the 15-inch dribble bands is the band spacing.
Yes.
Okay. And so when you do our 15-inch dribble banding, you're not necessarily trying to position that band where the crop's going to be planted, right? But if you're planting 30-inch row corn, and you're banding on 15-inch centers, we're not trying to go between that either, right? We're not trying to go between your rows. We're literally, it's meaning that we're not trying to track with your planter passes, right? So on average, the furthest you would be away is, I think it's 6.75 inches. On average, the furthest you would be away is 6.75 inches.
From any band at any given time.
At any given time, right? So
I'll take your word for it.
I've thought about this and wrote it out, and it's 6.75 inches.
Okay, so when you're referring to 15-inch, 9-inch, 6-inch spacing, that's
the
wanted to give the folks the reality of what that really looks like.
On average, you're about 6.75 inches away from any row. Okay. I'll also just mention these 24 locations. Some of it was done in the spring, some of it was done in the fall, some of it was done in no-till. Quite a bit of it was done in full width tillage.
Okay.
So that has been my baseline, 5 bushels.
5 bushels.
That's been my baseline, right? So my job is to innovate, help our company, help our customers, help our people innovate to the next level, because we always want to do better.
Right.
That is my job, and I'm not going to apologize for that. That's my job, right?
Yes, you should see when Jake comes running into our office and saying, "Oh my gosh, I just finished looking at another research trial, and this is going to do this many bushels." And I'm like, "Okay, slow down. Let's talk through this. Is this something for today or 5 years from now?" Well, 5 years from now, but I'm just telling you, this is the first round.
Yeah.
Okay, good to know.
Yeah, absolutely. I get excited about this
Yes.
stuff, right? Right.
we love the innovation. We're very lucky to have a Jake Bossenkemper
Well,
on staff.
I mean, I don't know if you're lucky. And sometimes you're probably not lucky, but I appreciate that anyway. So 5 bushels has been my baseline. So how do we do better than 5 bushels? And that's where we start the conversation.
Okay, let's get started.
All right, so we've seen this slide, but I do need to go through it again because we're going to see some slides next that are identical. And we need to kind of understand the baseline. And then once we kind of explain this slide, we don't have to explain the next 2 slides. Okay?
Okay.
Okay, so this is my nutrient placement study. I now have 16 different locations. And at each of those locations, there was at least 6 replications of each treatment per location. Okay? That's quite a bit of small plot data, just FYI. Okay?
Sure.
The treatments in this nutrient placement study were, first of all, let me back up. Every treatment here is strip till. So strip till is the same for every treatment. The nutrient rate was the same for every treatment. That nutrient rate was at 22 nitrogen, 50 pounds of P, 75 pounds of K2O, 15 pounds of actual sulfur, and a half a pound of actual zinc. So that was the same rate across all these nutrient placements as well. Okay. So we had a non-fertilized control. So no fertilizer whatsoever, just strip tillage. That yielded 243. Okay. We had a broadcast before strip till treatment. So in that treatment, we broadcast applied that same rate of fertilizer on the soil surface and then strip tilled through that. So the only fertilizer that got incorporated was the fertilizer that was incorporated by the strip till bar.
Sure.
Okay. That yielded 252. So fertilizer works.
Fertilizer works. Good.
We know that.
Okay.
The next treatment was ExactStrip before strip till. So in that case, I applied that same rate of fertilizer on 30-inch centers, and then I strip tilled right back through the middle of that fertilizer band. So,
and your strip till bar is a little bit aggressive, right? So it could throw.
Yeah, we know that one of the reasons this treatment hasn't yielded like I thought it would, because in the beginning, I thought this was going to be the best treatment.
Right. You thought, oh, it's going to just run it right down into the ground and good to go.
Incorporate it over the root zone. That's what we want, right? It was not. It was only about a bushel better on average than the broadcast. And that's because I'm highly confident that the residue cleaner was moving a good chunk of that fertilizer. You know, not all of it, because we clearly had increased yields relative to no fertilizer, but it clearly was moving some of it away from the row.
Sure.
Okay. The next treatment is ExactStrip after strip till. So in this treatment, we strip tilled, came back, blew that fertilizer right on top the middle of that strip till row. Okay.
So you kind of opened up that row a little bit. You kind of worked the ground right there. Do you think that had something to do with the fertilizer getting into the soil a little bit better, soil profile?
Yeah, I have no doubt that increasing that doing tillage, making some pore spaces, making some air spaces probably did help the fertilizer move down a little bit. But even without that, we know that when you band apply fertilizer, it overwhelms the negative sites, the negatively charged soil, and it can move down as much as about 4.5 inches or so. Okay. That work was done by Iowa State. We can go back or by the USDA in Ames near Iowa State. You can go back and look at some other videos where we've talked about that. Okay. So that treatment yielded 259. So about 7 bushel better than the broadcast treatment. Okay. And that's what we've talked about a lot of 7 bushel. Okay. The injected 6 to 7 inches yielded 1 more bushel than the ExactStrip after strip till. So putting it in at 6.5 to 7 inches deep was only 1 bushel better than blowing it on the soil surface. Okay. So on average, that's what we found, and that's what we talk about when we talk about ExactStrip. So 7 bushels more than 5, last time I checked. Is it changing the world? No, but it is progress, and that's what we want. Okay.
Bushel wise, it's maybe not changing the world, but application method, process timing, amount of people, you know, it does make a difference, right?
Yeah. I mean, you're already farming the land. If you can get 3 more bushel for basically almost no increase in cost, why wouldn't you? Right?
Yeah,
you're already buying the seed, you're already applying the herbicide.
Jake, before we move off of this slide, you know, to help the folks at home, we are talking about not doing tillage. All of this has some sort of tillage with it.
Yep.
What do you see when you do ExactStrip banded on no-till ground?
That's a great question. 7 bushels. I'm not kidding you. In the distance study, where we figured out how close we actually need to be to get a yield increase, that was all pretty much all done in no-till.
Okay, I know
Okay.
a lot of folks at home, have a lot of no-till being acres that they go into corn the next year.
Yep.
So not having a strip till bar and just being able to do exact strip, that's the environment we're going to see for those folks.
Yeah, absolutely.
Okay.
And have almost as many locations as I do here, but literally 7 bushels is the average yield increase in no-till.
Okay, great.
And it's 7 bushels here too. So I bet the yield increase on average is 7 bushels.
7 bushels. Okay. 7.
Okay, so this is great. This is a great start. Okay. We have 16 locations now. So now, once you have that many locations, you can start asking that data more questions to really help you narrow in on where I can get the most bang for my buck.
This is
Okay.
where production and research usually split. Okay, we got 16. That's good. Let's go.
Yeah.
Jake says,
Okay.
no, let's ask more questions.
All right. So what happens if we look at this data? So in total, there were 16 sites. What happens if we look at this data at the 7 sites that had the lowest response to P&K? Okay.
Lowest response.
Yeah.
So
So on average at these 7 locations, we only had an 8 bushel yield increase to applied fertilizer.
Okay.
We're going to look at some more data in a second where we had much higher responses. Okay. But at these 7 locations, we only had an 8 bushel yield increase.
you're saying, we didn't really see big yield increases
From fertilizer,
from
period.
fertilizer.
Yeah.
And let's just take the 7 sites, the lowest sites. Okay.
Yes. Yep.
We're with you.
So at these sites, there was only about a 3.5 or 4 bushel yield increase between broadcast before strip till and the exact strip blown on top of the soil surface.
Okay.
So not 7 bushels,
Not 7 bushels.
not 7 bushels. Interestingly, the injected 6 to 7 inches deep was a few bushels better than the exact strip on the soil surface. Okay, so that injected 6 to 7 inches deep still kind of shined even at the lower responding sites. Okay, but what happens if you go to the 9 highest responding sites? So at these sites, we had a 16 bushel yield increase on average to applied fertilizer. And now the exact strip after strip till, so when you blow the fertilizer on top of the strip till berm, now it yielded 10 bushels,
Almost 10 bushels,
better
yes.
than the broadcast. Okay, so when we have a high response to fertilizer, we see an even bigger yield increase to the exact strip. And by the way, now the exact strip on the soil surface had an identical yield to the injected 6 to 7 inches deep. So what this tells us is that when you have a high demand for nutrients, it needs to be banded in the root zone.
So when do you know that's going to happen?
That is a great question. And that's actually the probably multi-million-dollar question. Okay. Because Katie, the truth is, and you asked me a very good question about this data before, and I still haven't done it, but yes, I have all the background soil fertility levels for each one of these sites. Is it organized real well? No, I'm not going to lie to you, but I do have it. Okay, and I can get it. But I'll tell you what I'm highly sure it's going to say before I even organize it. It's going to say that the fertility levels weren't as different. It's going to say that the background fertility levels weren't as different as you think between the high responding sites and the low responding sites.
Okay, so what you're saying is your soil test levels for P and K are all relatively about the same across all the different fields, no matter if it's high response or a low response.
Generally, yes. Generally, I'm saying that because you have to remember that when I do this research, I'm always looking for moderate to lower testing sites because I'm doing soil fertility research. If I select a site with 250 ppmk and 60 ppmp, there's a decent chance I may get no responses. I mean, I'm trying to separate different fertility placements. So it's pretty important that I have a site that should be responsive to fertility at some level.
Right. You kind of want to have a clean slate to start when you're
Absolutely.
doing research.
So that means that in general, I'm gonna guess. I'll figure it out, but I'm gonna guess. I bet, for example, I bet the 16 or the 9 responsive sites might have had a K level 150 part per million. But I bet the sites that had little responsive fertility had 160 ppmk. I mean, I think it's going to be that close.
Well, we're looking forward to seeing all of those data sets put together for us.
Yeah, I need to do that. You're right. Okay, so background P and K levels don't always explain how many bushels you're going to get out of a nutrient application.
Okay, so is it hybrid? Is it weather? What are the things that are causing these?
It's all of the above.
Yep.
Okay. So we also know that some hybrids respond more to fertility than others. Fact. Do we know which ones those are when we buy them? Unfortunately, we don't. Okay. I mean, we there's been some researchers that have thought that's a good idea to characterize them and understand that, and it is a good idea. But it's almost impossible because hybrids move through the system so quick.
Right.
Okay. So absolutely hybrid is a factor in this. Weather is also a larger factor in this. So in other words, if it rains a half inch every other day, your soil test potassium concentrations could be pretty low and you're going to maximize yield without fertilizer because you need water in the soil to move potassium toward the root. You need water in soil for potassium to be in solution for the crop to take it up. Okay. When it gets dry, potassium uptake by the crop goes down dramatically.
We have a great video on that too from a few years back. We stood in a ditch.
Absolutely.
It was hot out.
Yeah, it was. Absolutely. Yeah. And that is proven fact. Okay. So the weather has a lot to do with this. So when you have dry soils, you need a higher concentration of potassium in the soil to maximize uptake.
Right.
Okay. And when you band it in the root zone, that is going to happen. Okay. General root health has a lot to do with how effective a root system is at taking up mineral nutrients. Okay. Soil texture has a lot to do with how effective a root system is at taking up mineral nutrients. Roots are not going to be able to effectively explore heavy clay soils as effectively as they could explore a nice drain, loam, or silt.
Mm-hmm.
Okay. That is going to play into this too. So the answer to the question is, when you apply fertilizer in any given year, you don't know how much you need. You don't. Okay. So one of my arguments for ExactStrip is because you don't know, you want to make sure you're placing those nutrients in a way that the crop roots are going to see the highest concentration possible.
In other words, if you don't set yourself up for success, you can't have success.
Absolutely. That's a great way of putting it. Yes. Okay.
That's why you got me, Jake.
And this next figure we're looking at the same data.
Okay.
It's just a different way of looking at the data. Okay. And I think it helps kind of explain this whole concept a little bit better. So on the bottom axis, all I did was I organized the sites from least responsive site to fertilizer in general to highest responsive site to fertilizer in general. The black line going through the middle of that graph is just the average response to fertilizer. And that includes all 4 treatments we talked about. That's just the average yield increase to fertilizer. Okay. The gray line is the average yield increase across those sites to the broadcast application. Okay. So in other words, on average at site 16 with the highest response, we had roughly a 23 bushel yield increase to fertilizer in general. Well, we only had about a 16 bushel yield increase to the broadcast application. But with the ExactStrip surface band, we had a 30 bushel yield increase. So we doubled the yield increase over broadcast applications.
So when things went well, it went real well.
When demand for nutrients was high, there was a dramatic yield increase to banding those nutrients and increasing the concentration of nutrients in the root zone. Okay. On the other side of things, when there was no response, there was no difference to the way you placed the mineral nutrients because the demand for nutrients was not that high at that site. Okay. And I have said from the beginning that this technology best fits for farmers that, for whatever reason, are struggling to build P and K levels to optimum or above. I've said that from day one. Okay. And this data shows that clear as day. Okay.
If you're not building levels, the old adage would be, well, just pour on more fertilizer because eventually it'll build. But that's not always true. Sometimes those spots are the spots that are using the most fertilizer and gaining the most yield and constantly taking it up into the plants.
Yeah.
And I think folks have a hard time sometimes, thinking that thorough.
Yes.
So having that fertilizer close to the roots and letting the roots actually use it is what
Yeah.
you're kind of getting after here.
And Katie, the truth is that if you look at average fertilizer rates and you look at average crop yield, in general, we are not even applying removal rates. Okay. And it's for good reason. We're raising huge crops. And when you look at the cost of replacing the nutrients that crop removed, it's a lot, right? So, we sell fertilizer. If you don't want to do ExactStrip and you want to build every field to 250 ppmk and 50 ppmp, sure. But last time I looked, not a lot of people are doing that or can afford to do that, right? And of course, you're going to be more focused on building ground that you own. You're going to be less focused on building ground that perhaps you're renting or is in a dicey 10-year situation. So, talk to your AFAs, figure out where this has the most bang for you, or if it's something you even need to do, right? Okay, so probably enough on that. And the last comment I want to make is, remember, I applied for P&K of 50/75.
Jake, we did say that we're going to go through the whole family of ExactStrip's, and we're only on the first review piece.
This is what I'm going to focus on
Okay.
most, okay?
Okay.
So I can guarantee you that at some of these sites, 75 pounds of K was not enough.
Okay.
But because I concentrated in the root system, we turned, hypothetically speaking, that 75 pounds of K maybe into 125 pounds of K, okay?
You kind of artificially trick the plant into thinking it's a better environment, and then the roots often concentrate in that environment and try to use what it can.
Yes.
It's nutrient efficiency.
Yes, absolutely. All right, so we'll move on.
It is hard to be your translator sometimes.
All right,
Hopefully I'm doing a good job.
So that's what I'm going to call ExactStrip P&K. You might change that, but that's what I'm going to call ExactStrip P&K.
Okay.
So we just talked about ExactStrip P&K. We talked about how you could use it. We talked a lot about when and where and why and how, and how you could potentially use it to get the most yield out of that system.
Let's show the folks the next piece you've been working on.
Okay. So now we're going to talk about ExactStrip nitrogen. And we touched a little bit on this in the research review, but we're going to go into a little bit more detail now. Okay?
Yep.
All right. So the first slide I just have on here is a study that I did looking at out-of-furrow starters. Okay. And I'm not going to go through all the details. You can look at this here. But essentially, I was applying 60 pounds of N, 10 pounds of P, 10 pounds of K, 10 pounds of sulfur, and half a pound of zinc. And on average, we had a 14.5 bushel yield increase to doing that. If you just look at the treatments without a cover crop, there was a 7.5 bushel yield increase. And the only reason I talk about this is when we're talking about ExactStrip N, we're talking about doing the same exact thing that I did here, but we're not going to use the planter. Okay? So same concept, but we're not going to use the planter. And I'm already telling you that at a whole bunch of sites over 3 years, there was a 7.5 bushel yield increase. Okay? So just kind of the background on the principle.
Well, this kind of opens up the doors for folks who don't have starter on their planters.
Absolutely. And so just to make sure the folks understand, when we start talking about ExactStrip N, now we're going to make a pass in the spring. After the final tillage pass, we're going to position nitrogen and probably some P and sulfur and zinc, probably 2 inches from where you're going to plant. Okay. And my expectation is that on average, you're going to see a yield increase by doing that relative to broadcasting those nutrients or relative to not doing those nutrients at all. Okay. All right. So we talked about this last time, but we're going to go deeper here in a minute.
Okay.
Okay. So this is a study that I started in 25 called my nutrient omission study. And the reason it's called a nutrient omission study is I'm pulling out nutrients one at a time, trying to understand when we further develop this ExactStrip N concept, at the end of the day, what's going to ROI best for our customers and what makes sense for us to make sure we have in this blend. Okay. So the first thing you'll know, I basically want to point out one thing. Okay. So I have 100 pounds of N banded 3 inches from the row, which yielded 246. Now I put 25 pounds of P, 10 pounds of K, 15 pounds of sulfur and a half a pound of zinc. And we got, what is that, Katie? A
7.
No, it's more than 7. 246. Yeah, you're right. It's about 8 bushel. Okay.
Write that down, everybody. I can do math.
But when we broadcast applied those same nutrients, we only had about a 3 bushel yield increase. Okay?
Jake, did you put fertilizer on in the fall as well, or is this just strictly, for this reason?
At this location, there was no other nutrients applied in the fall. Okay. But that's actually where we're going to go next.
Oh, okay. Sorry.
Okay. So just more evidence that band applying nutrients 2 to 3 inches from the crop prior to planting definitely can provide a yield increase relative to broadcast.
I think folks are probably pretty used to using this 100 pounds of broadcast nitrogen up front. And so now you're talking like what, a 12 bushel increase to just adding a little bit more of, what'd you say, phosphorus, potassium, sulfur, and zinc. Okay.
Yes.
And then, concentrating that once again into a band close to the root zone.
Right. That's exactly right. That's exactly right.
But you do not want to do this before you do tillage. Like you don't want to hit it with a field cultivator afterwards and work it in.
No,
you want it to lay on top.
You don't want to move it from the root zone.
Right.
You want this to be close to the root zone. So you're going to do this after your final tillage pass in the spring. The advantage to this over putting it on with the planter is you're going to have probably 2 or 3 weeks in the spring where you're waiting for it to warm up and dry out for perfect corn planting conditions. So you have the opportunity for either us to go out here and do this with our floaters and our post machines with RTK guidance, or if you're a farmer that already has a post machine and you have RTK guidance, or you want to pay to have the switch turned on, you could do this yourself because this is not a suspension. This is a clear liquid. This is going to flow like liquid 32%.
Okay, that's good to know.
Okay, so that's the advantage over ExactStrip P and K, is that this is a clear solution, and this could be done by anybody with RTK.
So Dr. Jake, we always want to maximize every trip across the field. And so if we're making this past early spring before the planter rolls, is there anything else we can throw in the tank to maximize this pass?
I've asked that question, Katie. Yes, I have a figure up here with a study that I call ExactStrip in additives. So if you're going to make this pass, is there something you could add to the tank to further enhance the yield other than just from that fertilizer? And Micro AZ is one product on here that provided roughly a 5 bushel yield increase. And that's roughly what I've seen from Micro AZ in other studies over a whole bunch of locations. Okay. There are some other products in here like Levosol Zinc Receptor that were slightly better than Micro AZ. And I'll continue to investigate these products. For now, my recommendation would be use Micro AZ because I've seen how consistent it can be. If you're going to do this, I would absolutely put Micro AZ in with this application method. Okay. So the next study is pretty important. Okay. And
I thought every study was important.
Well, every study is important, but this helps us understand if I apply fertilizer in the fall, what might I expect from ExactStrip nitrogen in the spring? So if I'm doing both. Okay. What might I expect to get? Now, this study was done at 5 locations, 3 in 2024 and 2 in 2025. Okay. So the first thing I want to say is that by exact stripping P and K relative to broadcast, we had a 5.6 bushel yield increase on average over these 5 locations.
Okay.
So not 7 bushels,
5.
5.6. But these are 5 different locations, and we just talked about how sometimes the yield increase can be bigger or smaller, but more evidence that ExactStrip increases yield relative to broadcasted nutrients. Okay. If you do what I'm going to call ExactStrip in on top of that, you got another 2.3 bushel. And that is just applying 60 pounds of nitrogen and 10 pounds of sulfur. Okay.
So are you using ATS as your product then? Is that why you've got sulfur in there?
Yes, I'm using ATS as my product. And remember, I already applied fertilizer in the fall. There was already 15 pounds of sulfur applied in the fall.
Okay, now we're up to 20.
So this is 10 pounds on top of the 15 pounds that was applied in the spring.
Okay.
And we still saw a 2.3 bushel yield increase to applying that nitrogen and sulfur close to the row. Okay. If you add Micro AZ to that 60 pounds of nitrogen and 10 pounds of sulfur, you got an additional 3.8 bushel yield increase.
And micro-AZ is that Azospirillum bacillicis. Am I close?
Brazilans, yeah.
Yes.
Brazilans.
Okay. And that is supposed to kind of enhance the root hairs, the fine root hairs.
It's not supposed to kinda, and I don't mean to, I don't mean to come after you. It does.
It does.
And it greatly increases fine root hair number,
which allows for more uptake into the
of
plant.
water, mineral nutrients, you name it.
Well,
Okay.
we haven't talked about micro-AZ yet, so I thought we should just kind of clue in the folks that are first timers here and make sure they know.
And the reason that I'm so confident when I say that is there's been a lot of work done in Brazil that has very clearly helped us understand the mode of action of micro-AZ. And all that evidence down there points directly at more fine root hairs. And the truth is, Katie, fine root hairs really make up the bulk of the root area of a root system. You can't see them unless you use a microscope, but they're there and they're important.
Okay.
Okay.
So when you add in micro-AZ, you gain a little more yield.
Yep.
And
Now-
probably for those reasons that's what I wanted to make sure the folks understood.
Yep. Now, when you add another 20 pounds of P to that nitrogen, there was actually no additional yield increase over micro-AZ. Okay. So that just tells us that 50 pounds of P that was applied in the fall with ExactStrip was probably enough. And that's okay, right? I mean, we're trying to understand how to get the most out of this for our customers.
Sure.
Okay? And I'll do more of this in the future. But the bottom line is you increase yields by 11.7 bushels per acre over broadcast applied nutrients without spending any more money on nutrients. You got 11.7 bushels per acre. Yes, you had to buy the micro-AZ. Yes, you had to pay for the upcharge of the ExactStrip, but you didn't spend that much more money to get basically 12 more bushels.
Okay.
So using this technology in conjunction with one another, I would also argue would increase yield relative to, broadcast applying nutrients or not doing any of this, of course. Okay. I know that was a lot. All right. But have AFAs give me a call if you want to understand more about that. Farmers, get a hold of your AFAs to get a hold of me, and I can explain more of what I did there.
If you don't have an agronomy field advisor, you can always call our Davenport office and we can get you to the right person.
Absolutely.
Dr. Jake, this next study that we're walking into now, the nitrogen is important, but when we talk about starter, we're often talking about phosphorus and how much phosphorus do we need? How close do we need to be to the plant? If we've got those cold soils, we want to have that zinc alongside of it. And we can link some other old videos in here to understand that, because that's not what we're really talking about here in this study. But help the folks understand what this study is about and why we're looking at the phosphorus piece to this study.
Yeah. So Katie, when you talk about placement of nutrients, you almost have to rank them in importance. I mean, placement of nitrogen in itself can increase yields for a couple different reasons. And we'll talk through those reasons, okay? Number one, if let's say you're using the case of broadcasting applying nutrients, particularly urea or UAN, which those are the only two nutrients, nitrogen nutrients you could broadcast, but the urea portion of those nutrients can do something called ammonia volatilization. Okay, and that happens when it's very dry after application, the wind's blowing, and it gets reasonably hot. Okay, it can also happen in high pH soils, but band applying nutrients can reduce ammonia volatilization significantly. So that could be one reason why banded nitrogen increases yield over broadcast applied nitrogen. Okay?
Sure.
The second reason why banded nitrogen could increase yield over broadcasted nitrogen is, I'm gonna give the folks an example to think about. In some years, in some places, when we apply anhydrous ammonia, particularly in the spring, we see that it could take a month or more for that nitrogen to move out of that anhydrous band in that crop to take it up. If that goes on long enough, there can be a yield reduction due to insufficient N, right? Because all that nitrogen was tied up in that anhydrous ammonia band and it couldn't get to the crop soon enough before there was a yield reduction, okay? So positioning a band of nitrogen close to the crop ensures that never happens.
Okay.
But does that happen every year all the time? No. Does ammonia volatilization happen every year all the time? No. So is there a general yield increase to band applying nitrogen close to the row? In general, yes. But it's going to depend on the environmental conditions and it's going to depend on the year. Now, I said, banding nutrients is relative. Phosphorus, on the other hand, phosphorus, extremely immobile. Phosphorus, doesn't move very far at all in general, but when the soils are cold, it really doesn't move. Like, it doesn't move, period. Right? When it's cold, roots don't move very far at all, and roots aren't very effective at taking up nutrients when it's cold. So that's why band applying phosphorus close to the row in a lot of cases matters. Okay?
So we got a whole lot of nothing going on when it's cold. So in order to make something happen, we got to get that phosphorus close to the root zone.
Absolutely. Okay. And that's exactly what this study tells us. So when we band applied nitrogen, whether it was on the row, whether it was 3 inches away from the row, whether it was 15 inches a row, or whether it was broadcasted, there really wasn't a yield difference between those placements of nitrogen. This is at 3 locations in 1 year. Not surprised by that. We just looked at another study that said there was a 2.3 bushel yield increase to band applying nitrogen. That also happened, right? It was just dependent on the environmental conditions of these locations.
Yes, but now let's move over to this 25 pounds of phosphorus that you added in.
So when you put 25 pounds of phosphorus in with that 127 pounds of nitrogen, now the placement absolutely mattered. And that's what I just said in plain English. Okay.
Yeah.
So when you broadcast apply that 25 pounds of P, we got less than a bushel yield increase. Okay. Because we didn't concentrate that P in the root zone where the crop could get it. In general, as we moved closer to closer placements, now there was a 7.5, we'll just call it a 5 to a 7.5 bushel yield increase with the 0 and the 3-inch placement.
Okay, great.
So when we think about placing nutrients, we have to think about what nutrients are in there. And even though there isn't always a yield increase to band applying nitrogen close to the row, there's almost always a yield increase to band applying phosphorus close to the row.
Right.
Okay? So that's the point that I wanted to make with this study. Did I make it?
I think so. I think you hit this one pretty good.
Okay.
I know you get really excited about all this stuff.
Okay. So the next study that I'm going to talk about, it's important because the thing we haven't talked about is we know that if you get too many nutrients, particularly nitrogen close to the row, it has a high salt concentration.
Right. I wonder when we're going to talk about this salt out and salt injury.
And it can cause salt injury. Okay. So I designed this study to really understand how high can we go and where are we going to see injury, or are we going to see injury? So what I did is I applied between 100 and 220 pounds of nitrogen. Broadcast applied that nitrogen, or I put that nitrogen right on the row, right where we were going to plant.
So you hadn't planted yet.
Hadn't planted yet.
You're going to plant.
I'm going to plant.
Okay.
And I would have bet you a large sum of money that the 180 and 220 pound in rate would have reduced corn yield.
So help the folks understand, like, how many days did you have in between your N application and your planting?
Probably a maximum of 4 or 5 and a minimum of the next day. Okay. So there's 6 locations here. Okay. But at no location did I ever see a yield reduction due to applying 180 or 220 pounds of nitrogen. Those high rates of nitrogen, even planting right back in that band of UAN. I was shocked. All right, so Katie, the important part about this study is that even at that 220 pound nitrogen rate, we didn't see significant yield reductions by planting right through that UAN band. And we know that can be something that we need to think about. We know band applied nitrogen can reduce corn yield if it's too close.
Sure. So should folks be worried about that? When would they be worried about that?
So we're going to look at the next slide, which is stand, and then we're going to talk about that in detail.
Oh, okay. That's great.
All right. So the next slide is the same data we just looked at, the yield data we just looked at. Now we're looking at stand. And the bottom line is there was not a stand reduction with band applied nitrogen right on the row, even at the 220 pound in rate. Okay. So we didn't see yield reductions. We didn't see stand reductions.
Now we see some of those orange bars are a little less than the blue bars. So when you say we don't see any stand reduction, do you mean we don't see it at all, or it's just not significant?
It's not significant. It's random error. It's a couple hundred plants per acre, which is random error.
Okay.
All right. And it flip-flops between the different broadcast and the band rates and
Yep.
so on and so forth, right? Okay, so just because I didn't find a yield reduction by applying a really high rate of nitrogen and planting right back through it doesn't mean that's something that we recommend, okay? In an abundance of safety, I think there's no reason from a yield increase point of view to apply more than 130 pounds of nitrogen. I don't think you need to band apply 220 pounds of nitrogen. I don't think you need to band apply 180 pounds of nitrogen to get the small 2-3 bushel yield increase that you may see, okay? But there is some risk involved, particularly when we get into sandy soils that don't have a lot of moisture in them, particularly if we were in an extremely dry spring where the soil doesn't have a lot of moisture in it, because moisture dilutes the nitrogen, dilutes the salts,
Yes.
causes something. There's actually two parts of injury when it comes to nitrogen that can injure the crop. There's the salt effect, which basically can keep the seed from imbibing water. The other part is ammonium toxicity, okay? And that happens when urea converts from urea to ammonia in reasonably dry conditions, and it stays in the ammonia form. It's the same compound as anhydrous ammonia, okay? But in moist soils, generally we see that conversion happen within about 3 days, okay? So ammonia toxicity is something also you would have to be worried about in drier conditions or with zero time between application and planting. But even if it's moist, that's probably not going to be an issue.
Okay, good to know.
So out of abundance of caution, I don't see a reason why you'd want to go over 130 pounds of nitrogen. And I also think you should position this band on purpose about 2 inches from the row, because we see that that's close enough to uptake the P and to uptake the zinc. And these are all things that I've looked at. There is no additional advantage from going to 2 to 0. So why increase the risk, okay? In case we get into a dry situation or a situation where injury could potentially be a problem.
So what if this is your only nitrogen application and now you're telling me you only put on 130?
Yeah, well, I'm telling you that the risk isn't worth the reward. So I wouldn't put on more than 130. You're going to have another application, another nitrogen application somewhere. That could be anhydrous ammonia in the fall, could be anhydrous ammonia in the spring, could be urea in the spring, could be broadcast applied UAN in the spring, could be a side dress application. There's lots of other options to apply your nitrogen.
Could just side dress,
could side
split
dress.
apply your UAN.
You absolutely could. In fact, that would be the preferred method in my opinion.
Right. In the old, you would want about 75% of your nitrogen on before 60 to 70%.
Particularly in continuous corn, yes.
Yes, before you plant.
Yes.
Or
yes.
start germination.
So the bottom line is that there's a lot of evidence that I have that band applying nitrogen, but adding some P and or maybe a little bit of K, sulfur and zinc with that ExactStrip nitrogen application can definitely enhance yields.
Okay.
The
next thing to think about.
The next step for me really is to go back and look, okay, if I'm going to put on 20 pounds of phosphorus with this ExactStrip nitrogen application, does that mean I should take 20 pounds of phosphorus out of my fall application, whether that be broadcast applied?
So you're worried about what the
ExactStrip.
total crop nutrients are going on for 1 year.
I think it's really important that the customers and the farmers out there understand that we aren't exactly asking you to buy more nutrients. We're asking you to use the nutrients that you're going to buy more efficiently to enhance crop yield. That's what we're asking folks to do. And that's really where all this ExactStrip stuff is really gonna sing. It's gonna help you get higher yields on the same nutrients that you're already purchasing. Okay. So that's gonna be kind of the next steps of where we're gonna go with the research going forward.
Okay.
I'll also just briefly mention that along with this ExactStrip, we're gonna have something called ExactStrip IDC. And that's to help fix iron deficiency chlorosis in north central Iowa. There's a whole Lead Academy session on that I encourage you to watch. But without ExactStrip technology, that would not be possible.
So we
that's
now
gonna be
have
part of the IDC family, or of the ExactStrip family.
We have ExactStrip P and K in the fall or spring. We have ExactStrip nitrogen, and we have ExactStrip
in the
IDC.
spring. Yep, and we have ExactStrip IDC, which could be probably done in the fall or the spring.
Okay.
But watch the entire Lead Academy session devoted to ExactStrip IDC to understand why I said probably in the fall or the spring.
I know.
Okay.
It's a good one.
Yeah, absolutely.
So folks, if you have any interest in any of these ExactStrip technologies or placement methods, make sure to reach out to your agronomy field advisors or get a hold of Dr. Jake or Phil, and they can point you in the right direction and get you set up.
Yep.
Thanks for watching today's Lead Academy. We hope you're having a great afternoon.
Thank you so much.
Lead Academy.
Liqui-Grow
Excellence
And agronomy
development.